Today I will be going over reciprocal identities, Pythagorean identities, quotient identities, plus some extra ones that are just good to know for the IB exam and in general. So first I will be going through some basic reciprocal identities. And what this basically means is, let's say we have theta here. And as I said in the last video, you can use SOHCAHTOA to find the sine, the cosine, and the tangent of a certain angle in a right triangle. Now, we know that sine is opposite over hypotenuse. So that would be, in this case, opposite over the hypotenuse. It would be x over y. Now here, let's name this side z. The cosine would be the adjacent over the hypotenuse. So in this case, relative to theta, it would be z over y. And tangent is opposite over adjacent, so it would be x over z. Three more trig functions that you may or may not have heard of in the past are cosecant, secant, and cotangent. Now, what's cool about these trig ratios is that they're actually the reciprocal of each other. That's why they're called reciprocal identities. So for example, cosecant would be the reciprocal of sine. So instead of being x over y, it would in turn be y over x. It would be the hypotenuse over the opposite. You will most commonly see this written as 1 over sine theta. The secant has the same relative theory, but it would be applicant to the cosine. So instead of being z over y, the adjacent over hypotenuse, it would be the hypotenuse over the adjacent. So in this case, it would be y over z, or 1 over cosine theta. Now the cotangent would be the easiest one to remember since it has the t here that stands for tangent, and you know that the tangent is there, and the co kind of implies it being the reciprocal. It would be, instead of x over z, instead of opposite over adjacent, it would be adjacent over opposite. So z over x, or 1 over tan theta. Now, a cool way to remember this is, if you look at the letter that these words start with, you would think that the cosecant would be the reciprocal of cosine. If your mind goes to that, just tell your mind to think of the opposite. So when you see the C, you know that it pairs with the S, with sine. Every time you want to think that it might be with cosine, you just think it's the opposite. This is actually the reciprocal of sine. And S would then be the reciprocal of cosine, so you just have to think of the opposite. So now let's go back to the example of my previous video. We know that the sine of pi over 3 is the opposite over the hypotenuse, so root 3 over 2. The cosine of pi over 3 is the adjacent over the hypotenuse, so 1/2. And I'll write tan over here. The tan of pi over 3 is the opposite over the hypotenuse, so root 3. So now let's practice with what we just learned. Finding the cosecant, the secant, and the cotangent. If you guys want, you can try these on your own right now. Would be the time to pause the video, and then you could double check your answers with what I get later. But yes, so we know that the cosecant is the reciprocal of sine, so it would be as easy as just flipping the fraction to get 2 over root 3. The secant is the reciprocal of cosine, which is 1/2. So the secant of pi over 3 would be 2. And the cotangent would be 1 over root 3, since it is the reciprocal of tan. This could be helpful when given the sine of an angle in a certain case, whatever that may be, and if they ask you to find the cosecant, then you know what to do. Another example in which reciprocal identities could come in handy is, let's say for example, you're given pi over 6, and the problem tells you that the secant of pi over 6 is 2 over root 3. And they tell you to find, let's say, the tangent. Now, you know by the properties of the secant that it is the reciprocal of cosine. And what's cosine? Cosine is adjacent over hypotenuse. So since this is the reciprocal, it's the opposite. And now you know that the hypotenuse is 2 and the adjacent side is root 3. Now, if this wasn't a triangle that you had memorized, then you could use the Pythagorean theorem to solve for the last side. But since we know what this triangle is, we know that this side is 1. And now since you've used this to solve for your triangle, you know that the tangent would be the opposite over adjacent. Now let's move on to the Pythagorean identities. The most basic of them being sine squared plus cosine squared equals 1. And if you see a similarity with this and notice that it says Pythagorean, you know that the Pythagorean theorem is a squared plus b squared equals c squared. And here you can see the resemblance. Knowing the Pythagorean identity sine squared plus cosine squared equals 1 can come especially in handy when you're given a problem like this. When you have sine and cosine in an equation, which you can't have two separate ones in an equation, so you have to change one of them so that they're the same. Now here you have sine squared x, which you know that when you add it to cosine squared, it equals 1. So you can manipulate this identity by subtracting cosine squared to each side. So now instead of this being 3 times sine x squared, it's actually 3 times 1 minus cosine squared x plus 4 cosine x. And now you've simplified the problem in which you have the same trig function. Now with whatever the problem they ask, let's say it gives you a separate formula and you're told to solve for x, the angle, you could continue going. But for now, I just wanted to show how you could use this equation, manipulate it, and change it into an equation in which you have the same trig function. I went ahead and just wrote down the two quotient identities that I'm going to be talking about in this video. And the first is tan theta equals sine theta over cosine theta. And if you see here, just like the reciprocal identities, it's the same thing. The cotangent would be the reciprocal of the tangent, and it applies to this identity as well. This identity can be used in, for example, a problem in which you're given cosine and sine, and you need to get rid of one of them, but none of them are squared, so the past identity, the Pythagorean identity, wouldn't apply. So what you would do here is you would add 6 to the other side to get 3 cosine x equals 6 sine x. And then what you would do here is you could either go both ways. I prefer tan theta, so you would divide both sides by cosine x to then get 3 equals 6 tan x. Divide both sides by 3, and then you get 1/2 equals tan x. Now, this could be expanded on a much greater scale, and the difficulty can get a lot harder. So, knowing the basics, knowing that sine over cosine, whenever you see it, you want to simplify it into tan theta, and it could make your work so much more concise. It can make everything so much easier. The last two identities I'm going to be briefly mentioning are sine 2 theta, which is actually 2 sine theta cosine theta, and cosine 2 theta, which is actually either 2 cosine squared minus 1 or 1 minus 2 sine squared theta. And as you can see, they both have 2 theta. And these are just identities that you also want to memorize just in case you see in a problem cosine 2 theta or sine 2 theta. You know that you want to simplify it into these ones. I've seen a lot of cases in which this shows and then you have to end up dividing it, which could also show up as the tan theta identity. But yeah, so these are just some identities that you want to memorize. Just kind of always have them in the back of your mind to make your work simpler and easier. And in the next video, I'll explore this a little bit further with some examples just in case this was confusing. But this is just the basic information before we move on.